Have you ever wondered why some salts are so colorful while others are completely clear? The reason lies in the ions that make up the salt. A salt is typically colored when either its cation or anion has the ability to absorb certain wavelengths of visible light. This process often happens when transition metals are involved because of their unique electronic configurations. For example, the d orbitals of transition metals can absorb light, leading to the creation of vibrant colors in the salts. Now, why does this matter? Well, understanding the color of salts isn't just about aesthetics, it's a useful tool in analytical chemistry for identifying chemical compounds, especially in lab experiments. So, let's explore how the color of salts can tell us a lot about their chemical structure. Let's start by looking at some of the most common colored cations. Copper ions, for example, are often found in salts like copper sulfate. This salt has a beautiful blue-green color, which comes from the copper 2 positive ion or copper 2 plus. The color arises from the way the copper 2 positive ion interacts with light, absorbing specific wavelengths while reflecting others. Similarly, chromium ions, which are the chromium 3 positive ions found in salts like chromium sulfate, give a striking green color. Manganese, on the other hand, forms pink salts like manganese chloride when it is in the manganese 2 positive state. This shows how even small changes in the metal ion can completely alter the color of the salt. Iron also forms colored salts, with the green hue of iron 2 positive salts like iron sulfate being quite common. Not only cations but anions can also contribute to the color of salts. One of the most famous colored anions is the permanganate ion, which is MnO4 negative. This ion gives a brilliant purple or pink color to salts like potassium permanganate. This ion is often used in redox reactions due to its vivid color, which makes it easy to spot in the laboratory. Another interesting colored anion is the chromate ion, CrO42 negative. It's responsible for the yellow color in salts like potassium chromate. These colored anions play a huge role in both the chemical and industrial applications of salts. They're often used as oxidizing agents or as indicators in titrations. Their distinctive colors make them stand out and be easily identified during experiments. Now, let's move on to alkali and alkaline earth metal salts, which are generally colorless. This is because they do not have transition metals in their structure, and thus they don't have the ability to absorb visible light. For instance, sodium chloride or table salt is completely colorless. Similarly, potassium chloride and magnesium sulfate are colorless as they only contain ions like sodium positive, potassium positive, and magnesium 2 positive. These ions lack the d orbitals that transition metals possess, so their salts do not absorb any visible light. This makes them perfect for uses where a colorless compound is needed, such as in food, medicines, and other chemical processes. Their purity and transparency are key to their versatility in various applications. Colored salts are more than just visually appealing, they play significant roles in chemical analysis and reactions. For example, potassium permanganate, with its purple hue, is used in redox titrations. When it reacts, its color changes, giving a clear indication of the reaction's progress. The ability to visually track these changes is crucial in determining concentrations in solutions. Colored salts are also used as indicators in acid-base titrations, where a shift in color marks the end point of the reaction. In industries, these salts are often employed for their oxidizing properties in various chemical syntheses. From the lab to industrial processes, these salts are essential tools that help chemists achieve precise, reliable results. To sum up, the color of salts is a fascinating topic that helps us understand the underlying chemistry. Whether it's the transition metals in copper or chromium salts that absorb light, or the colorless nature of alkali and alkaline earth metal salts, each case reveals something important about the structure of the compound. Colored anions like permanganate and chromate are not just beautiful, they have vital roles in chemical reactions and industrial processes. Understanding these colors can help in identifying compounds, tracking reactions, and even making practical applications in industries like food and medicine. Chemistry is truly all around us, from the salts in your kitchen to the chemicals in the lab. I hope this session helped you see how even the smallest details in chemistry have a big impact on the world. See you next time with more exciting insights into the world of chemistry.